Hi, welcome to Cracku. In this video, we'll be looking at quadrilateral areas formulas and some questions related to it. This is one of the most important subtopics under geometry, and geometry itself is so vast, and quadrilaterals is a very important topic. So we'll look at the formulas and then some questions related to it. So first we'll be talking about cyclic quadrilateral. Cyclic quadrilateral is nothing but a quadrilateral with all four of its vertices lying on the circumference of the circle. So a circle is drawn, right, and you have the quadrilateral has four vertices. If all four vertices lies on the circumference of the circle, right, that constitutes a cyclic quadrilateral. Right, so cyclic quadrilateral, because it's inscribed inside a circle, has some interesting properties. We'll go through the properties. So cyclic quadrilateral always has supplementary angles. Opposite angles are always supplementary. So as you can see in the figure here, right, if this is x and this is y, right, x plus y will be equal to 180. Supplementary is when two angles add up to 180. So opposite angles are always supplementary. So these two are also supplementary. So in a cyclic quadrilateral area, so now S is the semi-perimeter, which we have learned from the Heron's formula for the area of a scalene triangle. So S is basically A plus B plus C plus D divided by 2. And if you take, this is the formula for area of a cyclic quadrilateral, where root of S minus A into S minus B into S minus C into S minus D. Now the exterior angle is equal to the opposite angle of its remote interior angle, right? So basically CBX is equal to ADC, right? So this angle is equal to this angle. Now half into one diagonal and sum of the offsets drawn to the diagonal. So let's say the diagonal is drawn from D to B, right? So sum of the offsets will be A to the diagonal here and C to the diagonal here. So this is, let's say this is X and this is Y, right? So the sum of the offset, so the, and let's say diagonal, so the area will be half into dB into sum of the offsets, so X plus Y. So Ptolemy's theorem states that the product of the diagonals equals the sum of the products of the opposite sides. So basically product of the diagonals, so let's say AC into dB will be equal to sum product of the sum of the opposite sides. So AD into BC plus AB into DC. Right. So we'll come to the other. So for a trapezium, area is equal to half into sum of parallel sides into distance between them. So this is the trapezium, let's say. Right. Let's say this is A and this is B, the two parallel sides, and it's separated by a height h. So the area will be half into A plus B into h. For a parallelogram, the area is equal to base into height, right, or product of two sides with the sine of the angle included. So basically a parallelogram drawn like this, where the opposite sides are parallel. Let's say this is length and this is the breadth, right? So we can draw a height here. So the area is length into height, right? But it is also length into breadth, and let's say this angle is A, so length into breadth into sine A. So it's basically like area of a triangle where it's if this is x1 and this is x2 and this angle is A, right? So the area will be half into x1 x2 into sine A, and since this is a quadrilateral, right? So it's 2 times that, since this angle is also A, right? So it would be basically 2 times that. So it's just basically length into breadth into sine of A. Now rhombus, which is basically a shape with all 4 of its sides equal, right, but and diagonals intersect each other, but the diagonals are not equal. So if the diagonal, let's say this is A and this is B, area of rhombus is equal to half into AB. So this is another important neat formula that you guys can use, right? Number of faces in a solid, I know it's not exactly related here, is given number of faces in a solid plus the number of vertices is equal to number of edges. Let's just take cube as an example. Right, number of faces is 6 and number of vertices are 1, 2, 3, 4, 5, 6, 7, 8. And number of edges will be 12, right? So 14. So moving on, we will be looking at area of different geometrical figures just as this thing. So triangle is half into base into height, right? Rectangle is length into width, right? Trapezoid, as we discussed, is sum of the parallel sides into the height. Parallelogram is base into height. Circle, everyone knows, it's pi r square. Rhombus, we just discussed, it's half into product of diagonals. Square is nothing but diagonal, half into square product of diagonals or side of the square, right? And kite is half into product of diagonals. So a kite is basically a figure, a symmetrical figure, right? It is symmetric about this diagonal, right? This angle is equal to this diagonal and this side is equal to this side and this side is equal to this side. So that's basically a kite. So, and one more important property of a quadrilateral is sum of the three sides must be greater than the fourth side. So basically a quadrilateral like this, right? So for all four sides, A plus B plus C should be greater than D. And you can, so this is one of the basic properties, similar to how triangles sum of two sides should be greater than the third side, similar to that. Let's look at some questions. Right, trapezium PQRS has PQ parallel to RS. Right, PQ is equal to 4 centimeters, RS is equal to 6 centimeter. The diagonals of the trapezium meet at a point O, and the area of the triangle is POQ. Area of the triangle POQ is 24 centimeters square. What is the area of the trapezium? Right, so we'll draw a trapezium, right, and let's say the diagonals intersect. Now we're given that PQ is parallel to RS, right, and PQ is given to be 4 centimeter, RS is given to be 6 centimeters, so RS is greater. So PQ, R and S. So this is given to be 4 centimeters and this is 6 centimeters. So the diagonals intersect at O, and so triangle POQ is given to be 24 centimeters square. So we need to find the area of the trapezium. So now basic formula of the triangle, half into base into height, right? So the base of the triangle POQ is 4 centimeters, so half into base is 4 centimeters, and we will assume this as the height H1, right? So H1 is equal to 24, right? We get H1 is equal to 24, 48, 12. So, but we need to find the entire height. So we can extend this perpendicular, right? This part can be H1, right? And this part can be H2, right? And using the similarity of triangles, right? So since this angle is equal to this angle, right? And with a similarity, triangle POQ is similar to triangle SOR, right? So 4 by 6, right? The ratio of the heights should be in the same proportion. It will be equal to 2 by 3, and we know H1 is equal to 12. So H2 will be equal to 18. So we know the total height as H1 plus H2, which is equal to 30. Right, so now using the area of the trapezium formula, half into sum of parallel sides, which is 6 plus 4, right, into the height, right, which is half into 10 into 30, which is equal to 150. So the area of the trapezium is 150. So a parallelogram has adjacent sides measuring 8 and 12 units, and the angle between these sides is 150. So what is the area of the parallelogram? Right, so let's say this is 8, right, and this is 12, right, and this is given that this particular angle is 150. Right, so we can either do it, so it's also, so we'll try to find, since we gave the formula as area of a parallelogram is equal to this thing base into height, right? We'll try to find the height. So this part will be 90 degrees. So since the total angle is equal to 150, so this will be equal to 60 degrees. Right, now using the trigonometric formula where we can use, since this is a perpendicular and this is the hypotenuse, right, cos 60 will be equal to, and let's say this is the height, h by 8, and cos 60 is equal to 1 by 2, so height is equal to 4. So since the formula is height into base, so 12 into 4 will be equal to 48. Right, we can also do it as we said, length into breadth into sine of the angle between them. So which will be equal to 8 into 12 into sine 150. Right, so which is again 96 by half is equal to 48. So in this question, we're given that in a rhombus PQRS, rhombus is a figure where all four sides are equal, but then the diagonals are not, but they intersect each other, right? The midpoints of the sides of PQ, QR, RS and SP are W, T, U and V, right? And O is the midpoint of where the diagonals intersect. This is O, right? M and N are midpoints of OV and OU respectively. Right, then find the ratio of the area of the pentagon MNURV to the quadrilateral WTNM. Right, so let's start off with writing the diagonals. We'll write PR as A, right, and SQ as B. Right, so PR is A, SQ is B. Now we'll find the area of the triangle SRQ first, right, which will be SQ is given as B, so half into base, right, and height is A by 2. So SRQ will be equal to AB by 4. Let's draw another line here connecting V and U, creating that symmetry. Right, so considering that VU, which is the midpoints of SR and RQ, right, triangle SRQ is similar to triangle VRU, right. So now given that and using the midpoint theorem, if SQ is equal to B, right, and so given that this is similar and this is the mid connecting the midpoints, the midpoint theorem states that VU will be equal to B by 2. And now that we know the area, so the area of the triangles will be in proportional to the square of the ratio of the sides, right. So it will be 1 by 4th of the area of triangle SRQ. So triangle SRQ being AB by 4, triangle VRU will be 1/4 that, so will be AB by 16. Triangle VRU will be AB by 16, and again by symmetry OVU will be AB by 16. It's symmetrical, it's literally the mirror image of that. And now that we are given that M and N are midpoints of OV and OU, right, so we know that this part is B, right, so this will be B by 2. Again using the midpoint theorem where M and N are midpoints of OV and OU, this will be B by 4. So again using the midpoint theorem formula where some of the, now let's find the triangle area of the triangle OMN, right. So and OMN will be similar to OVU, again using the same midpoint theorem formula. And since the side is half of the side of OVU, right, so the area will be 1/4 of that. So if the area of OVU is 1 by 16, OMN area will be 1/4 of AB by 16. So triangle ONM formula will be AB by 64. And now by looking to area of the pentagon MNURV will be equal to the quadrilateral OURV minus the triangle OMN. So we know the area for UVR, which is AB by 16, OVU, which is AB by 16. So total area of OURV will be AB by 8, right? And subtracting AB by 64, which will give us 7 AB by 64. So area of the pentagon MNURV will be 7 AB by 64. Right, now we need to find the area of the trapezium WTMN. So writing down the rough formula for a trapezium will be half into sum of parallel sides, which is WT plus MN, into the sum of the height. So let's say this is X and this is Y. So it will be XY. So similarly, what we did with the horizontal diagonal, we can do with the vertical diagonal to find the area. So first of right off the bat, since this is B by 4, we know MN area, right? SQ is equal to B, and using the midpoint theorem formula where WT is midpoints of SP and PQ, WT will be equal to B by 2. So sum of parallel sides will be B by 2 plus B by 4, which will be equal to 3 B by 4. Right, we'll substitute that in the formula. So it will be half into 3B by 4 into XY. So 3B by 8 into XY. So we have taken that PR is equal to A. Right. So from symmetry, we know that OR will be equal to A by 2. And we've used midpoint theorem everywhere. So this is the midpoint. So this length will be A by 4. And this is again midpoint theorem. So this length OX will be A by 8. So this length midpoint theorem will be A by 8. Like again, this whole thing is A by 2. Right, this part will be A by 4. So A by 2 minus A by 4 will be A by 4. So Y to O will be A by 4. So now adding it up, we have taken the value of X as A by 8 and value until Y is equal to A by 4. This will give us 3A by 8, which is equal to the height or the distance between the parallel sides. So half into 3B by 4 into 3B by 8, which will be equal to, right, this is B, so this is A, so this part is A. So 9AB by 64. Now we need to find out the ratio between the two sides. So MN URV divided by the WTMN, right? So this is 7AB by 64 by 9AB by 64. So ratio will be equal to 7 by 9. So the sum of the lengths of the parallel sides of a trapezium is 30 centimeters, and length of the parallel sides are in the ratio 3 and 7. One of the non-parallel sides is perpendicular to the two sides. The area of the trapezium is 135 centimeters square. Find the perimeter of the trapezium. So we can just draw it out since we know that one of the non-parallel sides is perpendicular. We know the ratio is 3 and 7. So this will be 9 and this whole thing will be 21. Right? And the area is sum of parallel sides, which is already given as 30. So half into sum of parallel sides into the height is equal to 135. Right? So we know this is equal to h is equal to 9. So this will be 9. Since this is given as 9, this will be 12. right? To find the length here, you can just use Pythagoras theorem. As 9 square plus 12 square is equal to root of 81 plus 144, which is equal to root of 225 is equal to 15. Is equal to 15. So perimeter will be 9 plus 9 plus 21 plus 15. So this is 30 plus 24 equal to 54 centimeters.